Hello, chemistry class. I am here. I'm going to make a video about lesson 4 and 5 that I gave you last Friday before we left school, because I've had a lot of questions on that. 1, 2, and 3, the first 3 lessons seem to be a little bit more self-explanatory. But if you have questions on those, please contact me so that I can help you. So my plan is to divide lesson 4 into 2 videos, and then I will do lesson 5. So we'll see how this goes and see if this can help you. Grace is here with me also so that she can she can ask questions and maybe help along the way. So lesson 4, types of reactions. There are 5 types of chemical reactions: synthesis, decomposition, single replacement, double replacement, combustion. Okay, before we even start, this is what you need to have out. You need to have your lesson 4 notes, your lesson 4 homework, you need to have a periodic table, and you need to have the polyatomic ion reference sheet, because we might need to use that to see how different elements combine. We need to have charges and things like that. So get all those things out so that you are ready to do this. We're going to first talk about a synthesis reaction. In a synthesis reaction, it's a composition or a combination. We're going to take 2 things and add them together, and it's going to make a compound. Okay, element plus element yields a compound. This one is pretty straightforward. We always have only one compound here as the product. So if you're following along on your notes, the example they have H2 plus O2, and that makes H2O, which is water. Remember that hydrogen and oxygen are some of those diatomic atoms that always occur with in 2s if they're by themselves. So it has to be an H2 plus an O2 equals H2O. And now we would need to balance this equation. We've got 2 hydrogen over here and 2 over here, but we only have 1 hydrogen here and we have 2 here. So we're going to have to put a 2 right here, which means now we have 4 hydrogen, so we're going to have to put a 2 over here. That is a balanced equation right there. Okay, let's look at the next one. Mg plus S. What does that equal? We would have to look on your periodic table, and Mg has a +2 charge and S has a -2. So when we do this and reduce, it just becomes MgS, and it's all balanced. We don't have to put anything there. 1 Mg here, 1 here, 1 S, 1 S. So we don't have to worry about that. I'll erase this. And the next one is Li plus Br2. This is another diatomic element right here that always has 2s. Remember that? Those 7 elements that made a 7 on the periodic table? That's one of them. So when we put those together, let's look on the periodic table. Li has a charge of +1. Br has a charge of -1. So together they make LiBr. And we need to balance this. I'll use another color to balance it. Here we have 1 Li here, 1 here, but we got 2 Brs here, so we need 2 over here, so we'll have to put a 2. Now we have 2, so we got to put a 2 there. So now it's balanced. Okay, that's synthesis, where you've got One element plus one element equals a compound. And you might have to use the periodic table like this to see what the compound is that it makes. So let's move on to the next one, decomposition. In decomposition, it's the other way around. We start with a compound and it breaks down into two elements. Okay, it's the opposite of a synthesis. So now we have a compound that uses an element plus an element. Decomposition reactions often require energy such as heat, light, or electricity, something to break them down so that they become two things. So let's look at an example. We got H2O is going to break down into H2 and O2 because hydrogen and oxygen are both diatomic elements. If you don't remember what that is, go back in your notes or look that up someplace online so that you remember what it is. There are 7 of them and they make a 7 on the periodic table, if you remember when we talked about that. So here we have our equation where H2O separates into hydrogen and oxygen, but they both have to have 2's. We only have 1 O over here, so we're going to have to put a 2, which gives us 4 H's, so we'll have to put a 2 over here. So now it's balanced. Okay, let's look at the next example. There's 2. Okay, Grace just asked a question. There's 2, there's 2 oxygens here, but she said, oh, there's only 1 here. But this 2 out in front makes it 2 oxygens and 2 oxygens over here. Okay. The next one is NaCl. That breaks up into Na and Cl2. Again, Cl is one of those diatomic elements that only occur with 2. It's one of those 7. So again, we've got 2 Cl's over here. We're going to have to put a 2 over here, which means we're going to have to put a 2 there. And the last one is HgO separates into Hg plus O2, because O, oxygen is a diatomic element. And we got 2 oxygens here. We got to put a 2 here, which means we got to put a 2 there. Okay. Always, we always start for decomposition. We always are going to start on this side with 1 compound, and over here we end up with 2 elements. It's just backwards of the synthesis. So now I want you to get out your homework 4. The first page of homework 4 is all synthesis and decomposition. So we're going to do a couple of the homework problems so that you can see how to do them on the front page. 1 through 16, you should know how to do now from everything that I've talked about. Okay, 1 through 5 are synthesis reactions. Let's start with number 1. This is on homework 4. Okay, number 1, we've got Al, aluminum, plus bromine, gives you AlBr3. Now they gave it to you here, what aluminum and bromine are if you combine them. You could have done that yourself. Could have looked on your periodic table, find the charge for Al, find the charge for bromine, and see that it turns into AlBr3. Now you have to balance it. Okay, we got 3 bromine over here, and we got 2 of them here. When you have 3 and 2, you're going to have to put a 2 by the 3 and a 3 by the 2. Now we've got 6 bromine here and 6 bromine here, but we got 2 aluminum, so we're going to have to put a 2 here. And over on the side where it says coefficients, you need to write 2, 3, 2. The reason they're asking you to write the coefficients is because you're going to be able to see if you could reduce them. Because if you would have ended up with something like 4, 6, 4, you could have said, oh, look, I can divide everything by 2, and really it could be 2, 3, 2. So sometimes you make a mistake, and that's why they want you to put the coefficients there. Okay, so that is how you're going to do 1 through 5. It's pretty easy. They already gave you the compound. All you have to do is balance the equation so you have the same number on both sides. Now let's look at number 6. Number 6 is a word equation, and they want you to finish the word equation, then write the chemical equation and balance it. So now we got to do it all. There's only 2 of these. I'm going to do number 6. You do number 7 for homework. Okay. Magnesium plus chlorine gives you, this goes back to what we did so long ago, magnesium chloride. Remember, when it's just 2 elements together, a binary compound, just magnesium and chlorine, you end in an "ide." So it's magnesium chloride. Now we have to write it. Okay, that is completing the word equation. Now we're going to write the chemical equation. Magnesium plus chlorine. It's got to have a 2 right there because it's one of those diatomic elements. And what does magnesium and chloride make when we put them together? We got to look on our periodic table. Magnesium has a charge of what, Grace? 2. +2, and chlorine has a charge of what? -1. So we're going to switch those, and it becomes magnesium chloride. Okay, now we got to balance it. We got 2 chloride here, or 2 chlorine here, 2 chlorine here, 1 magnesium, 1 magnesium. It's all balanced. We don't have to do anything, and our coefficients are 1, 1, 1, because we didn't put anything out in front of there. Okay, that's not a 0, that's a circle to show that we didn't put anything out in front. So the coefficients are 1, 1, 1. All right, that is how you do 6 and 7. Now let's look at number 8. Number 8, balance the following decomposition reaction equations. This is like 1 through 5. They gave you, let's start with number 8. They gave you that KCl decomposes to K plus Cl2. The reason it's Cl2 is because that's a diatomic element. And so all you have to do is balance. So we got 2 chlorine over here, means we got to put a 2 here. Now that gives us 2 potassium, so we got to put a 2 here. And our coefficients are 2, 2, 1. 2, 2, 1. When there's no coefficient, we assume that it's a 1. Okay, that is number 8. Let's do another one. Let's do number 11. PbSO4 breaks down to PbSO3 plus O2. Okay, so they told you how that breaks down. You didn't have to figure that out, but you need to balance it. We've got, on this side, we have 1 Pb, that's lead, right? And we have 1 S, and we have 4 oxygens. Over here, We have 1 lead, 1 S, but we have 1, 2, 3, 4, 5 oxygens. So how in the world are we going to do that? I would look at, since this oxygen and this oxygen are connected to other things, I would put the 3 from this one in, wait a minute. No, let's try something else. All right, so we got 4 here and we got 5 on this side. So that means, oh, there's the 5 is divided into 3 and 2. You kind of have to do trial and error. If you start with a 1, and obviously we can't just have 1, 1, 1 because that doesn't work. So let's start with a 2 here. That gives us 2 leads. So then we'll put a 2 here. So now we have 2 leads and 2 S and 8 oxygen. And over here we have, I'm going to erase this and write this as 3 oxygen and 2 oxygen. So now that we put this 2, we got 2, 2, and now we have 6. So now we have the leads match, the sulfurs match, and we got 8 oxygen here, and we have 6 plus 2, so we have 8. So this is a balanced equation. Let's see what that wrote on there. Okay, so your coefficients are going to be, I don't have space to write it out there, they would be 2, 2, 1. 2, 2, 1. Okay, that is number 11. Now let's look at number 13. Write a chemical reaction for each of the following, then balance it. So it's written in words and you have to write it in elements. Hydrogen, don't forget that hydrogen always has a 2 because it's diatomic, reacts with nitrogen. Nitrogen also has a 2 because it is diatomic, and it makes ammonia, and it tells you that that is NH3. So now we have to balance this. We've got 2 hydrogen and 2 nitrogen. Here we have 1 nitrogen and 3 hydrogen. So since the hydrogen is 2 and 3, I would put a 3 here and a 2 there. So now we have 2 nitrogen, and we have 6 hydrogen, and we have 6 hydrogen, and everything is balanced, and our coefficients are 3, 1, 2. That is number 13. Okay, let's look at number 14. This is a good practice and review of what we did before. Okay, we've got lead, and it tells us it has a charge of 2. Oh no, and it's lead carbonate. So we've got lead and carbonate. What is carbonate on the sheet? Carbonate is CO3, and it has a charge of -2. So if we do this, we got PbCO3. That is lead carbonate, and that yields lead oxide. All right, so that's lead and oxygen. Lead is +2 and oxygen is -2, so that's lead oxide plus carbon dioxide. So that's how you write a chemical reaction from words. Now you've got to balance it. So we've got 1 lead, 1 carbon, 3 oxygen, 1 lead, 1 carbon, and 3 oxygen. It's all balanced already, and your coefficients are 1, 1, 1. So this is your answer to number 14. Okay, so that is the end of the video about synthesis and decomposition. I want you to watch this video, go through your notes, do the examples, and then finish the front page of homework 4 with this information. Then the next video, I'll talk about the other three types of reactions.